Okay. So this course, I think you have gone through the course structure which I have given. So this will be predominantly in the data engineering part of Google Cloud Platform. So Google Cloud Platform has many services which has to do with the databases, data warehouses, as well as messaging services, as well as storage. It gives a lot of options actually. So out of this, we will be talking in this course mostly about the data engineering part. And I have also outlined a few topics which will be helpful for real-time people, where a ETL tool, which is code-based, is something which we can also discuss at the later part of this course. So I'll get started. If there are any questions, maybe we can hold for 15 minutes, or maybe I can give a logical stop in my session. During then, you can post these questions, or meanwhile, you can type in the chat window so that I can go through at that point. Okay, so saying that, let's get started. Briefly, this is the agenda which we are going through for today. Like we'll discuss a bit about cloud computing types and service models. So what are the majors who are having who are the major cloud service providers and the advantages? Also, I'll give a course introduction around how this course is designed and how we are going through this course. So platforms and tools that we might need as part of this course is the next point which we can discuss. And we can discuss at least a few example services like BigQuery, which is the data warehouse from Google Cloud Platform, and cloud storage. And also have a look at the GCP console. Okay. So about me, a quick intro about me. Myself, Raghavender. I have been working for 15 years into IT, especially into BI and data management projects. Like I have been working in the full life cycle of data, starting from extracting from the source systems and presenting it as a metric and an attribute in the presentation layer with visualizations in the reporting tool. So I have worked into areas like data profiling, data extraction, data transformation, recently data ingestions into data lakes, and having them processed, loaded into your ADWs, and have them reported according to the dimensional modeling. So this is something which have been working for years. And I am a Google Cloud Platform certified into data services, as well as like I'm doing architecture as well recent days. So my interests are mostly into data ingestion of recent, because yeah, this is where we end up into the data lake. And once we have the data in the data lake, uh, applying transformations and having it loaded as per the requirements of visualization is what most of my career I worked with, and these are my areas of interest. So I provided a lot of solutions, at least for the data profiles, the movements, and the reporting which happens in the major BI solutions. So for me, this is my third engagement, which I'm currently working with for a lift and shift or rehosting of a current on-premise solution to a cloud-based solution. So I currently work for a cloud transformation project where we are transforming a Teradata-based data warehouse into a BigQuery solution. So BigQuery will be the main part and the main soul of our discussion during this course. And I will also explain how we can get through the other services when we work in BigQuery. So the introduction to all the services which are required for GCP to work with BigQuery is something which we are going to cover as well. Of course, we have a detailed slide, what we are going to discuss and how the course structure is going to be. So I worked for two projects for a rehost. Rehost is, when you say rehost, it's a lift and shift. Lift and shift is like you move from the existing on-premise environment to a cloud-based environment. So giving like a small introduction to cloud computing, what cloud computing is. So what it does. This is what we are going to discuss. Maybe you can pitch in so someone can, do you have some idea? What does cloud computing mean? Maybe just a one-liner or anything should be fine.
Using data center, of
you can give any rough guess. You can give any rough guess. Anything should be fine.
Using data centers of any cloud providers and hosting a environment over there.
Okay.
Whatever the data access which we are using in on-premise is shifted to cloud, and all the administration and maintenance and all the infrastructure is maintained by clouds.
Okay.
As well as GCP, we are just using the features.
I mean, in traditional on-premises, on-premise, so we have to depend on multiple services, like like which are kept on different hosts, which is always very tough to maintain. So since the cloud came into the picture, whatever the services that we required, it will inherited from the cloud itself. So we have this. I mean, so which is like better advantage than most of the on-premises that we have.
Okay. Okay. Most of you are correct. And does anybody know this term called scalability?
Yeah, that's what I was supposed to say. I forgot that.
Okay.
Yeah, scalability is the main.
Okay. Okay. And did you hear this word called availability?
Yeah.
Okay. Okay. So we are going to discuss these terms in later part, but yeah, let's see the basics of cloud computing. Let's start with each. So what basically cloud computing talks about is, it is a on-demand delivery of IT resources. So it is like you want these IT resources. Maybe it might be storage, it might be compute, it might be networking, or it might be analytics, anything. So nowadays, most of the major cloud service providers are offering AI solutions as well as many solutions. So anything, this is on demand of any of these IT resources. And this is delivered over internet. So you don't need to have any physical infrastructure to maintain or to upgrade or to do anything. Like, it is delivered to you through internet. Next is pay as you go pricing. Pay as you go pricing means, so you're going to pay according to what you have utilized. So you can spin up a server, you can spin up a database server or an app server and have it scaled for a huge load, but you at your customer side, you never saw that much load coming, or you have spin up the server with a minimal capacity, but your load is high. In those cases, you end up investing a lot of cost in your infra. So that's where cloud is going to be more beneficial, and it's going to adjust to your scale. Whenever you want to go for upgradation, you can do it anytime. So you are going to pay like what you use. So in short, instead of buying, owning, and maintaining the physical data centers, which we have seen, data centers or server, you are going to use cloud services. you can access these technology services such as computing power, storage, databases, as I explained, like you have all these services which are given by the cloud service provider itself. So when it comes to the services provided by them, there will also be a responsibility shared between the cloud service provider as well as the customer. So when you say customer, customer is the person who is requesting for these services from the cloud service provider. So there are a few responsibilities which are sitting on the customer side as well as on the cloud service provider. So we have a sharing model for these responsibilities. I'll take across these when we are discussing about each models. So there are models like cloud models based on deployment, and yeah, there are many. So we'll go through those topics. So, and it is on as needed basis. So whenever it is needed, you have the service. And it is provided by the major cloud service providers. At the moment, you see there are 5 majors, but mostly we hear about 3 of them. One being the first one in the market, that is AWS, secondly, Azure, and Google Cloud Platform. Please always remember, Google Cloud Platform is different from Google Cloud. Google Cloud Platform is a subset of Google Cloud. The platform is where you get all these services like data services, compute services, networking, storage, analytics, all these kind of services. So upon this, there is an umbrella, which is Google Cloud. So let's see briefly about the types of cloud computing, which we have based on deployment and based on service model. So you can have a cloud which is private to your organization, where you build everything and you maintain, and yeah, you are the whole and sole owner for the infra, for maintenance of upgradations. You maintain this, create and deploy the servers, and you do everything on the private cloud, which we have been working for some years. And now you see the second one based on deployment is the public cloud. Public cloud is something which is given by various cloud service providers. So it is owned by the cloud service provider or a hosting provider. So these people will host all the infra based on the customer requests. They provide resources, services to many organizations and users, but they have the right security so that the right organization and the right user picks the right resource. So this is all they manage through identity and access management, and also setting up the projects. Whenever there are many companies using their projects. So in short, each project which is in a public cloud is unique and used by one or the other customer. So there is no security lapse. Always the security is also one thing which the cloud service provider takes care of. So this public cloud is something which is accessed through a secured network. Typically, it is through internet, and like they have VPCs and through VPNs created. So any customer can request for certain resources, maybe storage or any kind, based on his requirement. So each customer uses a portion of that public data center. Maybe it can sit in a zone, or it can sit in a particular region, depending upon his presence. Like if there is a customer of mine who is having 5 locations, he's working out of Australia, he's working out of Europe, and maybe South America. So the cloud provider will be able to provide the services based on the zones, which is the point of presence for the client. So he can be local to that particular customer, and also have the data available, and also maintain a copy in the other zones as well. So this can also happen when you have a public cloud. So this is one difference which you see, which might not be available in private cloud. So when you have when you have your server or when you have your infra, so there there will be a disaster recovery, which you might have heard some cases, and there is an alternate server which you always set up actually. So this is all a huge headache which used to happen, which used to take care, which used to be the overhead which came up onto the each company which is implementing that private cloud. But when it comes to public cloud, this gets transferred to the cloud service provider. So please always remember, when you say public cloud, this is something which AWS or GCP or Azure or even IBM Cloud or like the major cloud service providers provide. And there is also an hybrid model. Hybrid model talks about a combination. Actually, it's a combination of public and private cloud. So you have an on-premise which the customer might currently have. So he has already invested a lot in his infra, but he also wants to use a public cloud. So there is a scenario where I want to host my business critical data in my on-premise environment. I don't want it to go and sit in a cloud because it might have security issues. So I'll keep my business critical applications as well as business critical data in my private cloud, that is on-premise, and have all the processing compute power, everything sitting in a public cloud. So that's how a hybrid cloud works also. So if really the customer doesn't want to go out of his on-premise environment, he still wants to stick with, it is also possible. That is about hybrid. And based on service, there is another type of cloud based on deployment, that is multi-cloud. So which is happening recently. Recently, you might have seen many projects which are working with their office servers as well as databases sitting in Azure, storage sitting in AWS. There might be data still sitting in Advantage. So you might have seen this kind of scenario also, which we might also see in the near future. So multi-cloud is where you have applications sitting in different cloud service providers. So some applications you feel that these are running faster. For example, Azure is more grown and more mature in terms of its data solutions. So that's if a customer thinks that he wants to work with the data solutions more on Azure, and he wants to have BigQuery for the data warehouse implementation because of its petabyte scale, as well as its columnar storage and all these latest features that BigQuery brings in, it's still possible. It's still possible between multiple cloud environments. Based on service model, we can roughly categorize into many types, but I have listed only the few important ones which we will be touching and which will be used in our discussion. So infrastructure as a service. So you are going to request for infra, but you're going to get all the infra which you want in terms of your CPUs, in terms of your storage, like whatever you want. You don't want to purchase it, but you want all this as a service from a cloud service provider. So this is the option which you take. So platform as a service. Platform as a service is something where you have your infra, you have your networking, you have your runtimes, all taken care by the cloud service provider. So you just, when you go with a platform as a service, where you start using your applications, customizing your applications, and maybe improve the performance of the applications, and also work with the actual application, developing the application and stuff. So just above the infra, you also want to push some more responsibilities to the cloud service provider so that he takes care of the runtimes, also the patching, installations, all this kind of stuff. Software as a service. So you want an existing software which is available, but you don't want to worry anything. You just want to use the product. In a simple example, you can say that platform as a service, taking an example of a database, you want to use MySQL. then you need to install, you need to upgrade, you need to maintain your databases in a platform as a service. But when you come to software as a service, you want to use the database directly, where you just give the name of the database and start creating tables into it. So when you use some cloud as a software as a service, you start using the product and start working on your development. Instead of working with an administrator to configure a lot of things, you want to use software as a service to directly focus more on your actual development activity. That's how these three service models are there. Let's discuss more in the next slide as well. So if you look at the three major cloud service providers, you have AWS, Azure, and Google Cloud. Google Cloud is relatively very late into the market, but it initially was started with its app engine in 2008. But when it comes to Google Cloud as a platform with application as well as compute and all this, it really started in 2013. So at the moment, to give a small gist, AWS has the major number of projects, major number of work in cloud. AWS is a proven CSP partner, as well as Azure. Azure is very much into the data solutions part of it, because it has its database, as well as the integration services and reposting services, which are mature enough. So Azure is also occupying a significant. But if you compare Google Cloud to both of AWS and Azure, it's picking up very fast. It's moving very fast. Of course, it is very late in the game, but the speed at which Google Cloud is expanding right now is very fast. It's massive, actually, because of its firstly because of its data warehousing capabilities with BigQuery, and also its reach in terms of network, because Google uses the same networking resources as well as the IO which Google by itself uses, actually. So it's the same infra across the customers as well as the company by itself. So there is no discrimination around it, and Google has the best reach around the world. So let's see a little more into based on deployment model, what can be cloud services. Like, starting from the bottom, if you are able to recognize some of the majors, you're able to see infrastructure as a service, starting from Amazon Web Services EC2 instance, and Google Compute Engine, as well as many other things. Like here, you get the infra as a service, and this is storage as service, which we have been using from some time. If you recognize OneDrive, Dropbox, Google Drive, these are something which we use storage as a service, where we get a certain limit of data which we can post in. And there is a platform as a service, which you can see Microsoft Azure, AWS, and App Engine from Google. Similarly, like, there are many other cloud service providers also which have this platform. Now we have this database as a service as well, where you have a cloud data store, Microsoft SQL, Azure, DynamoDB from AWS. So these are all database as a service. And you have function as a service also. Function as a service is apart from software as a service, you just have a runtime. You just have a simple function to run and give an output to some other server. Okay, so it doesn't need much of IO. It doesn't need much of the physical infrastructure. Then you just want to host a function as a service. So then you can use this cloud functions, Azure functions, and also the last one in this is software as a service, where you want to readily use the application directly. Salesforce is one application, Google Suite is one application, as well as any database. Like BigQuery is a software as a service. BigQuery, you don't need to set up a server. You just create your data set, start using the database. So you don't need to worry about the performance. You don't need to worry about the slots. You don't need to mention anything. So you just use the software just by naming the project, giving the data set. So that's how Google BigQuery is evolved also. So let's discuss a little bit, maybe in the next few slides, next 2-3 slides, and I'll give a logical break over there, and then let's take some questions meanwhile. So if I show you the Gartner's Magic Quadrant, so what this speaks about the cloud infrastructure and platform services. So this is the Magic Quadrant, which is proposed by the completeness of vision versus the ability to execute. So every cloud service provider can provide services, can have the projects lifted, shifted, as well as rehosted, refactored. Many things can happen, but the ability for the success is also something which is measured, and Gartner is one which gives these assessments. If you see, the major around this is Amazon Web Services, which is in the lead position, and both these three form the leaders quadrant actually. So they Microsoft being the second, Google being the third, but yeah, Google is the pace at which Google is really really converting their clients, as well as the number of wins which are recently happening for Google is very fast. The growth of cloud transitions, like cloud transformation projects into Google Cloud Platform, is high at the moment. Also, let's see a little bit at the comparison. Comparison was of the AWS versus Google. So it's a simple comparison which comes from Gartner again. So this is about the insights, the overall rating in terms of service implementation, as well as execution of the cloud services, working with them. Like AWS still stands to be at the top at 4.5, but versus Google at 4.4. But Google to reach to this overall rating level was pretty much quick. And we don't know what's going to happen in the next few years, but we definitely see that there is a surge in terms of projects which are moving to cloud transformation for Google Cloud Platform. So when we say cloud transformation, an existing project which is on-premise, where they have their own database servers, application services, they would like to move to cloud infra. They would like to rehost. Rehost is the first option, where you host the current on-premise to cloud services, or you can refactor. Refactor is something like also you start using the cloud native solutions. And also there are these kind of transformation can happen. So this is a comparison of Google versus Amazon. So as you have seen, we have discussed a little bit on cloud computing. What does it talks about, like how is it delivered? So if you see, explaining to a common person like what this cloud computing talks about, it can be any end user who is a mobile user or a laptop user or a printer or anything which is connected with a switch or a router to this cloud. So this cloud can give access to a virtual desktop or a software platform or an application which a user is trying to use, or he wants to access some data. So anything you can access servers, you can access desktop, like these kind of applications which an end user wants to access through internet based on the requirement, as well as whenever he wants, from wherever he wants, is something which cloud computing gives as an advantage. So talking about major services at Google Cloud, we can also go in depth in the next slides, but giving a flavor around what kind of services does Google Cloud offer, maybe let me explain a few. If you start with Google Cloud, there is data transfer service, like where you can have the existing data of the current customer, to be transferred to the new Google Cloud environment. Maybe it can be a data lake which can go and sit in cloud storage, or it can be a data warehouse which can go into a BigQuery, and it can be a relational database which can go into Cloud SQL or Cloud Spanner, many things. So Google Cloud also offers many services to Internet of Things as well as AI. So these are a little advanced topics which we can discuss in a later part, but not in this course. So there are management tools where Google Cloud offers based on its services. It is enabled with logging and dashboards where you can see what's happening with the resources, services, what's happening with the resources, what is the performance, what is the usage, what is the critical limit point of each of the resource, and whether is there any application which is going up and above a certain threshold values. This is something which you can monitor. So that's something management tools cover. There is big data services where there is a stack of services which comes in, starting from many services like Cloud Big Table, Spanner, Cloud SQL, BigQuery, Dataproc, many things around big data. So identity and security is where you can manage users accessing these applications, where you want to define some projects, you want to define an organization, and under the organization you want to define few projects, and under the projects you want to define some data sets for BigQuery to have the tables and views. And also this is the way you completely monitor how the services can be utilized by the users, as well as define some roles. And yeah, that's something which you can do. So also networking, there are networking services which Google offers so that it can connect between its applications firstly, and also it can communicate with the external applications. Storage and database, Google Cloud has a solution for storage. And when it comes to storage, you have cloud storage, which simplifies the type of objects, like the amount of data, everything depending upon your requirement. So compute is the compute power which you want to process certain jobs. You want to process certain jobs, then you need processing power, because with normal processing capabilities, you can't achieve execution of few jobs. So you need the high compute power. So that's where you start defining slots, and then you give the slots accordingly based on the performance required. So let's see a little bit more in depth into Google Cloud Platform. What does it offer? And what is this about? So Google Cloud Platform is offered by Google. It's a suite of cloud computing services. And most predominantly, please remember, this is the same infra that Google uses for its internal applications also. So this is widespread and works with the highest availability and very low latency. So this Google Cloud Platform is a subset of Google Cloud. And when you say Google Cloud, there is more under this umbrella. Maybe Google Cloud Platform is one, Google Workspace is other, and your normal Chrome and everything which Google offers is also a subset under Google Cloud. So it is initially launched in 2010, but April 2008 is when an application engine, which was announced by Google. It is currently grown more than 100 services right now. So the services which span around the buckets which I have just explained. So taking an example, networking, AI, database, and many other buckets. So it covers mostly big data, networking, computing, and many more. So it is available across 37 regions at the moment with 112 zones. So region is a specific area where you see some zones. Each zone will have kind of 3 data centers. So that's something, it is not that equivalent to AWS at the moment, but yeah, the reach is there with a point of POCs as well. So long-term pricing model with a committed use. So the best part of Google, while when we compare to its competitors, is in the pricing model. So when you have a committed use for 1 year or 3 years upfront, when you are able to give this commitment upfront, then there is a long-term pricing model which is very economical compared to that of AWS and Azure. So you have 57% savings on workloads when it comes to data flows, or when it comes to processing. Compared to its competitors, it is 57% less costly. So also Google Cloud Platform is been it's been priced based on second. So you pay for all the services which you have taken based on second, but when you come to AWS, it is based on hour. So this would be my final last slide for the moment, and I'll give a break to take up some questions. So lift and shift. So when you move applications to cloud as is without any change, so you have certain applications, maybe database applications, ETL applications, or front-end applications, you want to just move the applications, then this cloud transformation, you call it as a lift and shift. So this is also called as rehosting. So you just move the inline infra and move and host it on to cloud. So this is lift and shift actually. When you say refactor, you're trying to modify the applications to make use of the better use of the cloud environment. So cloud environment currently comes with certain advantages which you want to use by having the applications hosted on cloud, and that will require some time because you need to adjust to the current new cloud environment and modify the applications accordingly. So that is where you call this migration as a refactor. So you want to re-platform. So there is a third way where your customer might feel that nothing works with the current solution and he wants to move applications with major changes, without major changes, but taking a few benefits of the existing cloud environment. Rebuild is completely rewriting it from the scratch. You want to do the project completely new. Replace is you want to retire a certain applications and replace it with a cloud native application. Cloud native application, when it comes to cloud native application, these are you have these in-house applications which are being maintained by your customer from some time, but you don't want to use them, but you want to adapt to the new applications which are provided by the cloud service provider. Okay, let me take few questions before I go further. So any questions, if someone wants to ask, maybe they can speak out.
Yeah, hi, this is Bhanu.
Hi Anand.
No, this is Bhanu. Just one query I have. Let me assume that we don't have any background on this. We work on the just the on-premise. Okay. So this is the first doesn't have much idea on this cloud computing and everything.
Okay.
So this, whatever the course we are doing here, right? This will cover all the cloud, basically cloud platform concepts, like basic concepts, like for example, user access and authentication. Yes. All those it will cover, or basically this is because I see a big data or a data. So is this something different, or people like after doing this course, can I go for the certification, or what is basically just trying to understand more on this?
Definitely one thing, you can go for a certification based on a professional data engineer, because we are going to cover most of the components which a professional data engineer needs at a Google Cloud platform. Okay. So that's something which I can say. I can cover most of the topics because once we start using the tool, once we start jumping into these services, then we come to know more about it. But if I put a slide and start explaining each service and give a theory around it, that's not how cloud is going to work. Cloud is something which you're going to research a lot once you start using it. Once you start using it, you will come to understand a lot, actually. So I will cover most of the services which we are going to use as part of data services, like when working with data, how hosting data. But my primary focus will be on BigQuery for this particular course, because BigQuery is going to happen to be the largest data warehouse implementation across many clients. So you might have been hearing about DynamoDB and Redshift from many years, at least from 2015 from Amazon. But BigQuery to get to this point within this short time is a great achievement, I think.
Yeah.
So BigQuery. Yeah.
Yes, good. See, the reason why I'm asking is, let me assume that typically whenever we have this Google platform cloud, so the deployment, how all those will be covering, or it's more of a data this thing.
I initially had an idea to have a complete solution when it comes to data warehouse, how we are going to use the source, like replicating an example of source system, having it presented, placed in a data lake, and then have ADW around it and do some visualization around it. But that's going to seem to be a lot of time. But okay. I would like to cover maybe in the last week around these. I would also like to show a little bit like as I explained, and if you have seen the course structure I posted, you might have seen this. So this is the course structure which I have given. So I have given the platform as Google Cloud, and the major service which we are going to use are these two. But it's not that we are not going to discuss about identity and access management. You need it because for BigQuery, you want to configure anything, you need to work through IAM also, and you need to go through other services which are connected to BigQuery. So I propose that we also go through a tool called DBT. This is data build tool. This is the ETL tool, which is a code-based.
You can see your PPT actually. Are you showing something else?
Okay, yeah, let me share my screen. Yeah, so you're able to see the page where the syllabus from Durga is being displayed.
Yeah.
Okay, so an ELT tool is presented over here. DBT. Did anyone hear about DBT? DBT stands for data build tool. It is a code-based ETL tool. So you can have data read. So it is an ELT tool. So it is not used for massive data ingestions, please remember. So now most of the projects are going for cloud transformation. So they want to use any code-based ETL tool, which is kind of freeware. So DBT is one of that. And we will also be discussing about Airflow, because Airflow comes inbuilt in Google Cloud Composer. This is the runtime environment which does the orchestration for your DAGs to have any job orchestrated into a particular task and then get loaded. So how you would like to load or how you would like to version the code in Git is also something which I would like to cover in the later part. But please also remember, covering the BigQuery and associated services for Google is something which will be our main aim. And the last week, I would be discussing about the platform and how a real-time project would look like, and maybe one use case around the total data load also.
So what is the language used? Is it SQL, Python, Java, anything like that?
So we are going to use SQL itself. Mostly BigQuery will be a SQL-based kind of language itself. So if you are prerequisite for this will be you should know SQL, at least if you know SQL. But I will be covering, if you are still novice, maybe I will be covering a little bit into the create part, alter part, basics of DML, basics of ETL, EL, ELT, inserts, updates. I would be covering that, how you would like to load the data into BigQuery, and how you read data, how you make connections, like building one pipeline, standardizing, and like I would also orchestrating in a DAG, this kind of thing. So basically in a whole, we would work with Google BigQuery. So this is the data warehouse which Google Cloud Platform implements, and it's something which is happening in many projects actually at the moment. So many Teradata based solutions are getting moved to BigQuery, at least.
Sir, I am from SAP HANA side, where
Okay.
we have virtual models. So we were doing all the joins and all those things, but here everything we should write in SQL, and that need to be executed. Is that right?
True. Understanding of SQL is required. For BigQuery, I can show you the interface at the end, almost at the end of the session, just like in few minutes. But one thing I would say is understanding on SQL is important. You should know the SQL to understand BigQuery basics and its architecture. So one that will help in terms of data warehousing understanding. And I would also cover a bit into how ETL, how to query data, how to do batch loads, and also how to work with one ETL tool. If you are able to work with data build tool, then I think any other graphical user interface tools like Informatica or any tool will also be a very easy add-on for you. So I think working with GUI based ETL is very easy than that of code based ETL.
My question, I have one. So for this, would we in the GIS and Python and can go like what tools being applied like
Your voice was a little feeble. I was not able to understand you, but I understood that whether we use Python in this. But yeah, I would say Python at the moment we would not cover in this topic. But if you have Python knowledge or something which you would like to code something into Airflow and do more automation or something which you can extend around it. But for this course, Python knowledge is not compulsory.
And Unix is
understanding of Unix is well and good. It is it helps actually, because please if you are able to understand Unix, you will work with the cloud CLI. So whenever you, sometimes people might not be that familiar with the commands. So that's why you have the UI. So if I show you, this is the UI for Google Cloud. This is the opening screen. And if you would like to traverse to BigQuery, you just select it, and you can start writing your SQLs here. So you just name your project over here, and you just create a data set. Just say create data set. I want to create something, or maybe August. Okay. And you specify the region. I don't want a multi-region because sometimes it's costly. So members. Okay. And the region, you need to select a region, because currently, if you see, if you are in India and you want to use the best performance, you might need to select the zone which is near to you. So please always select something which is near to you. South Asia. Okay. And, there are some certain options which you can set at a data set level.
Sir, is there any like trial version for 1 month or 2 months like that?
Yes, actually Google gives you 90 days, whatever you are able to see on the top. Google gives you a credit of $300, and for a period of 90 days. So you can exercise this. Ideally, 45 days is enough to go across all the services, most of the services. But ideally, if you see, there are many services which comes in for this. If you see the all products. So not all is something which will be of interest for you because you work in a certain area. Maybe you work in the development, you work in the DevOps, or you work in the data engineering, you work in analytics. So each person might be required to get to know about some services, but not everything out of it. So traversing across these services, working with them, knowing the customizations around it, this is something which I can explain and take through. I can also take through how data engineering can be useful for you, and also work a little bit with the analytics part also. So we'll cover not advanced ones, but the ones which will be helpful for the data analytics. BigQuery is one, PubSub is one, Dataflow is one. So I'll touch all these topics. At least analytics parts, I will touch most of them in this particular course. Any further questions?
Are we covering any projects as part of this session?
Yeah, as I said in the last week, I would like to show a real-time implementation with all these platforms. One real-time implementation where we can pull data from an existing source system and have it in a data lake, and then have it loaded into our EDW layer, and then that's one thing which we can showcase.
Okay. Coming to complexity, like we know like basic SQL commands as part of our development work. So how complexity it is to learn BigQuery?
BigQuery, only few constructs is different. Please remember, BigQuery is a columnar database, and yeah, in a traditional data warehouse like Teradata or some things, you might have seen that it's mostly row based actually. So so there is a little understanding difference which you might need to know, but it might not affect anything in terms of an database developer. If you are a database data developer, if you are a BI data engineering developer, it doesn't matter. It is the way BigQuery organizes itself and implements its SQLs. So it is a columnar storage, not like a traditional RDBMS. So it's, if you see a traditional RDBMS, it's record oriented. So a set of data sets together. But here you see data is collocated by columns, not by rows in BigQuery. So, and also the way the columnar format is stored is in form of capacitors actually. So in simple, a query which ran in Teradata for 4 minutes had a best performance near to coming within 17 seconds in one of the recent implementations. So that's the power of BigQuery. So also the best thing you have seen just now, I created a data set. You can start creating tables directly without having any setup, actually, any setup of the servers, anything. So that's a bit about BigQuery.
Okay.
BigQuery and big data is different. BigQuery is a data warehouse. Big data is a more is a different implementation which we do in Hadoop, where you have components like Hive, Scoop, Big, and many other things. So in terms of whether to go with big data or BigQuery, if you have that question, if you are working on or going to work on some cloud implementation in the next future, then definitely BigQuery is one of the option, because this is the best data warehousing implementation which is happening in the last few days, especially in the American software IT market.
Sir, for this PLSQL also required PLSQL?
PLSQL, if you know, it's okay, but we are not going to do anything with PLSQL in BigQuery.
Okay.
We're
And just
last
question, sir, that like what would be the job roles, that we can apply after the course?
Yes. So there is data engineering role where a person can procure data and make it available for data scientists. There can be data analyst roles, which Also, BigQuery has this machine, as I explained, there is machine learning AI functionality as well as NLP as well as IoT already embedded in BigQuery. So you don't need to write separate models in Python or in R to get integrated to a database and get some model realization. You have these models coded in BigQuery already. So it's only that you call it, use it, and so that's something which is an added advantage. So BigQuery is also going to get more projects based on its ML capabilities. Okay, so if no further questions, maybe I'll end it here and we shall continue.
Hi, Raghav. Small
Yeah.
question. Yeah. Actually, the entire transformation that we do here with BigQuery only.
Transformation you can do with an ETL tool, but you can also write some SQLs which can transform and create jobs in BigQuery alone also. So for transformation, you can use a ETL tool, a ELT tool,
Okay.
like Database tool, or you can write SQLs and schedule them as jobs. The best part of it, maybe I'll cover tomorrow. In BigQuery, you can write queries, you can create tables, you can create temporary results and visualize directly in Looker. Directly, you can give the data set as a result to your reporting tool and start visualizing from there. So that kind of facility is also available in BigQuery.
Okay. I mean, this Airflow DAG, I mean, I'm aware of this Spark DAG, which is data processing tool that we are using one of the projects. So, I mean, what is the use for that Airflow DAG?
Airflow is an orchestration tool. It is like a workflow management.
Okay.
If you are aware of it, it creates some graphs. Those graphs will define how you want to load data. So this graph will have a certain tasks. The task will run a particular job back in BigQuery, and you want also to transform some data. So you want to run some job in DBT also. So then you start using Airflow. So Airflow is like a workflow management tool where you can specify a certain task with a certain dependencies.
Okay, it's not like any processing engine, right?
No, it's a workflow orchestration tool actually. Orchestration means if you know Informatica, you know there is a workflow manager where you define how you want to load each mapping and each session. So that kind of orchestration is something which we can do in Airflow.
Okay.
So, I mean, entire thing we are dealing with the batch processing, right? I mean, we are
Yeah.
not having any Apache Beam. Probably Apache Beam is replacing with the DBT. I think so. We are not doing any not real time or near real time something.
Real time we can achieve. I can give some introduction into it using PubSub. PubSub is the one. PubSub is a streaming service which Google Cloud Platform offers.
Right.
So that is where you define a topic and start publishing and get the subscriptions done. So that can also be done. And also for Apache Beam, there is data flow which implements the transforms, P transforms actually. So I can cover basics around it, but not in-depth
Yeah,
real-time
basics is fine. Yeah.
scenario.
Basics with respect to the data engineering, I think sufficient.
Yeah, that is definitely part of it. Yeah.
Because many projects they won't use the cluster of all the components, right? I mean, it could be like straightforward use cases,
True.
right? Yeah.
Will you cover any Power BI sessions, like 1 or 2?
Power BI, no. Power BI is not part of the Google Cloud Platform, but Looker, it is also called Data Studio earlier. Looker is the visualization tool. I can cover basic around it. How we can, in one of the session, I can use one of the BQ data set and start visualizing it from there. So, yeah.
That's really great. I mean, if you are able to cover like data engineering part, so that will be great.
Okay, yeah.
So what is how it is more beneficial than Snowflake warehouse, sir, BigQuery?
Snowflake is also one of the leading cloud data warehouses of recent. Snowflake is also, I should not say it's BigQuery is better, but BigQuery comes with the advantage of Google Cloud Platform, where you have all these extra data services which are already sitting, which will aid BigQuery to have the best performance. Like taking a data pipeline as an example, if you want to design a pipeline, you should definitely have a cloud storage which hosts the files which you receive, and that will act as a raw layer. And you would like to have a cloud run environment which can run some temporary jobs for you, get the results out of some shell scripts, and you always can send these talk to BigQuery with these services, with the existing services of Google Cloud Platform. So between the platform, between the services, the communication and traceability for logs, as well as BQ. BQ can also read data directly from a file which you store in a cloud storage. So this kind of facility as a cloud platform with BigQuery is an advantage which Google has.
Like, I've seen some of the organization, they are using cloud storage, Azure Blob, Amazon S3, cloud, Google Cloud. But I don't know why some of the clients still they are moving data to the Snowflake. So I was like, it's so confusing. Like, what's the point of using the blob storage then?
So depends upon the client's requirement actually. So if there is a data lake where the client wants to host it in files itself, if he wants to load it in terms of files in the cloud storage and then use it as per his requirement, then that is possible through cloud storage, and you can always query from BigQuery. And if you want to do analytics around the data, maybe is using it from the cloud storage and loading it into Snowflake for his requirement. But depends upon the requirement and the architect who is designing those solutions.
Okay.
Okay, then I will logically end the session here. Maybe we can continue tomorrow. Thank you. Thanks, everyone.
Okay.
Thank you.
Thank you. Bye-bye.
Thank you, sir.
Thank you.